Hello everyone, welcome to Shreyanna classes. In this video we will cover chapter 2 of computer hardware, logic gates and their applications. So logic gates. Logic gates is a basic component of any computer hardware. So a logic gate is made up of ICs or integrated circuits. Integrated circuits which accepts one or more inputs in the form of signals and gives out the output based on specifications. Now, logic gates are of two types. One is fundamental logic gates and derived logic gates. Under fundamental logic gates, there are AND, OR, and NOT gates, and under derived gates are NOR, NAND, XOR. We call it XOR, which is also known as exclusive OR, and XNOR. Now we will be seeing that under the fundamental, we will first cover the fundamental logic gates. So under fundamental logic gates, the first thing comes is AND. So the AND gate is represented by two or more inputs followed by this symbol. There is a symbol for AND gate. So an AND gate has two inputs. So depending upon how many inputs are there will be a certain number of bit configurations. So the formula of bit configuration is 2 to the power of n. N defines that how many inputs are there. So if there are 2 inputs, so there will be 2 to the power of 2. So there will be 4 bit configurations. So let us suppose there is an input A and input B, and the output is shown by Y. We have to keep in mind that the AND gate multiplies each bit to find out the resultant output. So if we draw the truth table, here is Y, B and A. So there will be 4 different bit configurations. We write like this. From the very right, we write like this: 0 1 0 1, then 0 0 1 1. Now it is multiplying. So 0 times 0 is 0, 0 times 1 is 0, 1 times 0 is 0, and 1 times 1 is 1. So it is basically saying that if both the conditions of inputs are true, then only the output will be true. So how do you define true? 0 stands for false, 1 stands for true. So basically, if both the conditions, or we can say that if both the inputs are true, then only the output will be true, or else if any one of them is false or both of them are false, the output will be false. Then OR gate. So OR gate is shown by this symbol. This symbol A, B, two inputs. Here also two or more inputs. Two or more inputs. So basically in OR gate the bits are added up. So if we add up the bits and we show the truth table, A, B, Y, so 0 1 0 1 0 0 1 1. So 0 plus 0 is 0, 0 plus 1 is 1, 1 plus 0 is 1, and 1 plus 1 is 1. So we are seeing that if any one of them is true, then the output will be true. So if any one or both the inputs are true, then only the outputs will be true. Now let us look at 3 input OR gate. So basically 3 input OR gate has 3 inputs, as already stated, 3 inputs. So basically it is adding up, so A plus B plus C. So the resultant truth table will be first of all we need to listen that how many inputs are there. There are 3 inputs. So depending upon the inputs we use the formula 2 to the power of n. So 2 to the power of 3 inputs are there, so 8. So we have to make 8 bit configurations. Okay, so 8 bit configurations. So A, B and C, starting from the very last, or we can say the LSB part. That LSB stands for least significant bit. If you don't know about this most significant bit or least significant bit, or you have forgot this part, there is a bell icon or the I card will be show up on this video. Just click on that, you will learn that what is the part and revise it, and then come and then look this video. So C, so from the very ending part we will write 0 1. So count it first, that how many blocks are there. 1 2 3 4 5 6 7. So we need to make another one, so total 8. So 0 1 0 1 4 0 1 0 1, so 8. Then make it 0 0 1 1 0 0 1 1, then 0 0 0, then 1 2 3 4, 4 zeros and 4 ones, 4 zeros and 4 ones. First 0 1 0 1 0 0 1 1 0 0 1 1, then 4 zeros and 4 ones. So 0 plus 0 plus 0 is 0, 0 plus 0 is 0, 0 plus 1 is 1, 0 plus 1 is 1, 1 plus 0 is 0. So in this way we will continue writing like this. So based on the tried and true fact that if any one or both the inputs are true, then only the output will be true. So from here we are getting this result. So there may be n inputs gate also. So there may be 2 input, 3 input, or n, or for 10 input gates. So depending upon the configuration, there will be changes in the system. Now we will talk about the three input AND gate. 3 input AND gate. 3 input AND gate. So 3 input AND gate is so A, B and C. So y equals to, since the bits are getting multiplied, so we will represent like this. So let us draw the truth table to understand a little bit more. So the truth table. There will be 8 blocks. Now we have made the truth table. So let us write 0 1 0 1 0 1 and 0 1 then 0 0 1 1 0 0 1 1, then 4 zeros and 4 1. Now let us multiply. 0 times 0 is 0. This becomes 0. So since we are all multiplying, anything multiplied by 0 is 0. For Boolean algebra is true also. And only at the last stage we are seeing that it is getting 1. So we have already talked about the law that if all the inputs are true, then only the output will be true. So it holds true also here also. Then the final gate is, for our fundamental gates, is NOT gate. So NOT gate, as we all know, it just complements whatever the input is being thrown at it. So a NOT gate is always a single input gate only. It doesn't have any other extra inputs, because it just deals that it just inverts. So if A is passed, A becomes A naught or A complement. So let us draw the truth table. Now we have made the truth table. So let us write, since there are only 2 inputs, only one input, so depending upon the formula what we have seen, that 2 to the power of 10, so 2 to the power here is only one input, so it will be 2 inputs, so bit configuration. So it's only, so let us write it like this, y equals to A bar, so or A complement or A naught. So y equals to A complement and 0 and 1. So 0 becomes 1 and 1 becomes 0. This is a basic catcher. It is also known as inverter, which is inverting whatever input is being given.